Good morning, guys.
Good morning, sir.
Good morning, sir.
Okay, so tell me what we were discussing in the last class, if I remember. Poisson distribution.
Poisson distribution.
Okay, very good. Any doubts, any questions? I hope all of you were able to find the answer of question I gave you. Okay, so in that module, now there is one topic left, which is about sampling techniques. Okay, so this is purely theoretical topic, sampling. So I have given you the material about this topic. So I would suggest you read that topic, and if you face any difficulty, we can discuss it in the class. So I'll give you just a brief idea about what is this sampling. Sampling is if you have to perform any experiment. So definitely you need some data, and the data you are going to get from samples. So you collect the sample and then you get the data from these samples. So depending on what experiment you have to perform, depending on what your outcome of interest is, so your sampling can be of two types. So let me share my screen. Okay, so the sampling can be of two types. One is called as probability sampling and one is called as non-probability sampling. So probability sampling is when all the possible samples for your study have got equal chance of getting selected. Okay, so suppose I want to know what is the average height of people living in Noida. So suppose this is the task I gave you, that you have to tell me what is the average height of people living in Noida. So you can collect sample in various ways. So probability sampling is when all the individuals living in Noida have got equal chance. Okay. So if I'm telling you that you have to give me the answer and your data, your sample size should be minimum 500. So what you can do? So either say like you are studying in MIT University. So probably you'll try to find out this. You'll try to collect this data from university itself. You'll just ask, do you live in Noida? And if someone says yes, I live in Noida, you take the measurement. Okay, you measure the height and then you record it, and you get data from 500 individuals like that. But that's not probability sampling. So that's called as non-probability sampling. Non-probability sampling is when everyone is not having equal chance of getting selected. Since you are taking sample only from MIT University, so not all the people living in Noida are studying in MIT University. So that is the non-probability sampling. If you go out, okay, if you go out and you take samples randomly from different places of Noida, that is called as probability sampling. So in probability sampling, each entity or each sample in your study has got equal chance of getting selected. And non-probability is when each sample is not equally or when each sample has not got chance of getting selected, right? So that is non-probability sampling. Now both probability and non-probability sampling are having different subtypes. So there are 4 subtypes for probability sampling, 4 subtypes of non-probability sampling. So you have to study these 4 subtypes for both probability and non-probability. So this material is already given to you, so that is purely theoretical. So I would suggest you read that. Okay, and if you face any difficulty, we can discuss that in further classes. All right, guys.
Okay, sir.
So that was we were supposed to study for module 4. So we are done with module 4. So we are done with module 1 and 4. So today I'm going to talk about module 2. And module 2 deals with correlation and regression. So these are the two terms or two topics that we are supposed to study. Okay. So before I start explaining correlation, you guys have to tell me what is this correlation? I'm sure you all have heard about this term correlation. So what is the general meaning of correlation? So you guys have to tell me. Okay, so let me ask who will tell me that. Adhish. Adhish. Okay, first of all, uh, raise your hands if you are present in the class right now. I want to know how many people are sitting in the class and listening. One, two, three, four, five. Five students or four students are they just okay. Adhish, switch on your mic.
Yes, sir.
So have you heard about this term correlation? Yes.
Yes, sir.
So batao, what do you understand by correlation? I'm not talking about statistical definition. Any definition that you know about what correlation basically tells us?
So correlation means they have they have uh, so it's like they move in same direction or like they are related to each other.
Okay,
Like
very good. Yes, yes.
if they are I mean, it can be termed as a positive correlation or negative correlation.
Okay, ठीक है, very good. Manaswini.
Yes, sir.
So, what do you understand with correlation?
Sir, I think it's the relationship between any two or more than two variables, for lack of a better term, and how, let's say, if there is some kind of change in one variable, then the effect that that change has on on the other variable can be termed as the correlation between them.
Okay, all right, very good. So, correlation is basically a relationship between any two, right? So, any two variables or any two entities or any two objects, if you find there is a relationship, we call it as correlation. So, that is a general definition. But in biostatistics, when you talk about, acha, so one student was raising hand. I guess it was Shivani. Shivani, you would like to say something about correlation before I start explaining?
Um, what correlation basically is, it's basically the relationship or connection between two or more things.
Okay. All right. So in statistics or in biostatistics, yes, Ishita, you want to say something?
No, sir. Actually, I was just lowering my hand. Sorry, sir.
Okay. All right.
Sir,
Yes. Yeah.
it can also be said like interdependence between two variables.
Interdependence. Okay. Yes. That is also true, but not entirely true. I'll explain why it is not entirely true. So correlation in biostatistics or in statistics is a relationship between two quantitative variables. Always remember this term, quantitative. Okay. If the variable is not quantitative, if your variable is qualitative, that cannot be called as correlation. So this, whenever you're writing the definition, you always have to write this term quantitative. If you don't mention quantitative, then your definition is incomplete. That is not complete definition. Okay. So relationship between two quantitative variables is called as correlation. Now you may ask, then if it is for quantitative variable, what if we are trying to find out relationship between two qualitative variables? So for that we have another term. So that is called as association. Not studying association in this particular module. We'll learn about it later on. Okay. So for correlation, you always have to mention it is quantitative variable. So quantitative variables can be anything: height, weight, blood pressure, blood sugar, anything that you can measure on a scale. Okay. So the correlation is of basically of two types. So one is called as positive correlation and one is called as negative correlation. So positive correlation is when one variable goes in one direction, the other variable also goes in same direction. अगर एक इंक्रीज करेगा दूसरा भी इंक्रीज करेगा, एक डिक्रीज करेगा दूसरा भी डिक्रीज करेगा, राइट? So that is called as positive correlation. Like your height and weight. So जैसे जैसे हमारी height increase करती है, हमारा weight भी increase करता है, right? So that is basically positive correlation. And negative correlation is when the two variables that you are studying, they move in opposite direction. अगर एक बढ़ेगा तो दूसरा कम हो जाएगा, एक कम होगा तो दूसरा increase कर जाएगा. So that's called as negative correlation. And if there is no pattern between these two variables, कि एक के change होने से दूसरा कभी कम हो जा रहा है, कभी ज्यादा हो जा रहा है, then that is called as no correlation. Okay, they are not correlated. All right. So for finding out whether there is a correlation between two variables or not, so we always go for we always try to see it visually. Okay. So let us assume I have collected this data on height and weight from 5 individuals. Now if I want to know whether there is any correlation existing between these variables, so what I can do, I can draw a scatter plot. Okay, and I can plot a trend line also. So that trend line is going to tell me whether there is any correlation existing between these variables. So you see, as the height is increasing, weight is also increasing. Okay, so from this scatter plot we can get some idea, but whether this correlation is significant or not, or whether there is actually some relationship, that you cannot find out from correlation from this scatter plot. So scatter plot will give you some idea whether there is any correlation existing or not. Okay. So all right, now okay, so far any doubts, any questions?
No, sir.
Okay.
No, sir.
So
All right, so let me ask okay, Tridev. Tridev.
Yes, sir.
Okay, Tridev. Tell me, what do you think if I try to find out whether smoking and lung cancer are correlated or not? So what do you think? What type of correlation I should expect, positive or negative?
So definitely positive correlation.
Definitely positive. Okay. Yukta?
Yes, sir.
What do you think? What should be the answer? Do you agree with Ridev?
Yes, sir. Yes, sir, there is a positive correlation.
ठीक है. Rupal?
Yes, sir.
Do you think both of them are right?
Yes, sir, it is.
Okay.
They are right. They are.
All
It is positive.
right. So anyone in the class who thinks that these three students are not right, they have some different answer. If any one of you in the class, please raise your hand. Okay. All of you think that the three students are right. And what I think is all these three are wrong. Now, who wants to go with me? So I'm saying their answer is not correct. So anyone who thinks I'm wrong, please raise your hand. Okay. So their answer is not right. Why it is not right? Just now I told you correlation is the term used for quantitative variables. Smoking and lung cancer both are qualitative variables. Whether you smoke or you do not smoke, whether you have cancer or you do not have cancer, these are qualitative variables. So we cannot study correlation between these variables, right? So that is not correlation. I hope you understood why I asked this question.
Yes, sir.
So always be careful. Correlation means quantitative variable only, not the qualitative variable. If I ask you whether height and weight, they are correlated. Yes, that's the right question, because both height and weight are quantitative variables. Okay. Now, one very important thing that so whenever you are studying this correlation, you always study correlation between two variables. So one variable out of these two is called as independent variable. One is called as dependent variable. So out of the two variables you are studying together, one is called as independent, one is called as dependent. So dependent variable is basically that depends on something. And independent variable is variable that does not depend on the other variable. So if I have to find out the relationship between height and weight, so what do you think? Which one should be independent? Which one should be dependent?
So weight should height is independent.
Height is independent and weight is dependent, because weight depends on height. So आपका weight can be decided by what is your height. पर आपका height कितना होगा ये आपका weight decide नहीं कर सकता है, right? So here it is pretty clear which one is independent, which one is dependent. But in some scenarios that may not be very clear कि कौन सा वाला dependent होगा, कौन सा वाला independent होगा. For example, cholesterol level and systolic blood pressure. So blood pressure depends on cholesterol level, or cholesterol level depends on blood pressure. We don't know. It can be either way. Okay, so in such cases, it is very hard to find out which one should be independent, which one should be dependent. So then you have to decide, you have to have some logic, which one you are considering as dependent variable and which one you are considering as independent variable. Okay. All right. One point. The other point is the question that you are asking should be logical. Okay, so you give some data to your tool or to your program for correlation, and you find out correlation. It is possible that from that tool you get some significant correlation, but in reality it is not there. Why that happens? Because the kind of variables that you entered, it does not make any sense that there should be any correlation existing between these two. For example, if you enter the shoe size and the income, you are trying to find out whether there is any correlation. What is the shoe size and what is the income? Is there any correlation? So that's not a logical question. ठीक है, आप अपना टूल में एंटर करोगे डेटा को एंड यू फाइंड आउट कोरिलेशन, वो कुछ तो कोरिलेशन दिखा देगा, बट डज दैट मीन कि आपका जूता का साइज डिसाइड करेगा आपका क्या इनकम होना चाहिए? नो. सो देयर शुड बी सम लॉजिक, some explanation that these two variables may be related with each other. Okay, so there should be a logical relationship that you are trying to establish. And one very important concept that you must know is causality. So what is causality? One is causing the change in another variable. So height and weight. So we know there is a positive correlation. If height increases, weight increases. But whether height is causing the change in weight or not, that you cannot establish through correlation. Correlation आपको just इतना बताएगा, yes, they are moving together. Maybe in same direction, maybe in opposite direction. But one is changing the other, that may not be true. Okay, so the example I always give is ice cream eating, drowning. Okay, so one guy collected the data that what is the consumption of ice cream every day. So he collected the data for certain number of days, ice cream consumption every day and number of people drowning, and he found out a positive relationship. So if there is positive relationship, that means as the ice cream consumption increases, the cases of drowning are going to increase. So do you think people are drowning because they are eating more ice cream? Is it possible?
Yes, sir.
How?
Only if the ice creams which are being manufacturing has been some contaminated with some microbes.
No, there is no contamination. There is absolutely no contamination.
Then it's no, sir.
It's not possible. But still you may see the correlation. So if there is a correlation, that means although they are related with each other, but this drowning cannot be caused by ice cream eating. So that means it is, so that you cannot establish the causality. Probably there is some other variable that is controlling both of these variables, and that variable is season. So this guy collected the data in summer season. So you know, in summers people eat more ice cream. In summers people go out more for swimming, and if you go out more for swimming, the chances of getting drowned is also more. So more people are going for swimming, more people are getting drowned, right? So it is basically the third variable which is controlling these two variables. So although they are related, but ice cream eating is not causing the drowning. It is something else. So clear? So through correlation, you cannot establish causality. I hope it is clear so far.
Yes, sir.
Okay.
Yes, sir.
All right. So now let me show you a video first. Okay. And after that, yes, Demetrius.
So this correlation is only for linear graphs, right? Because if there is a parabolic graph at
Yes, yes.
one point, yes,
Yeah,
sir.
I'll come to that. I'll come to that. Wait, don't worry. I'll explain that part also. और चलो आपने बोल दिया तो मैं अभी बता देता हूँ. So the correlation that you study, that you can study only if there is a linear relationship. Okay, so what do you mean by linear relationship? If one increases, the other also increases. So ये linear relationship को मैं explain करने के लिए let us take the example of age and BMI. So if you want to study the relationship between age and BMI, so you can have a different scenario. So if you study the relationship between age and BMI for say age 5 years till 25 years, you will find there is a linear relationship. As the age increases, BMI also increases. So that is called as linear relationship. But if you try to establish the relationship between these two from say age 5 till 65, then the relationship cannot be linear. Why it cannot be linear? So up to certain age, your BMI increases. So in the early age or till you are say young, your BMI increases. In the middle age, it becomes stable. Then although your age is increasing every year, BMI is more or less stable. And in the late age, what happens? BMI comes down. Okay. So if you consider the age group from 5 to 65 or 5 to 70, whatever it is, then you'll see it is not linear. But if you take the age band of let's say 5 and 25, you'll find out a linear relationship. So this correlation, you can study only linear relationship. If you want to study non-linear relationship, so there are certain other methods. Okay, so we'll be dealing only with linear relationship here. Is that clear?
Yes, sir.
Okay, so let me show you guys a video first about correlation. And then I'll explain it using one example. Okay.
Eager to head out on making it big.
All right, so you go through this video.
Hello, and welcome to the next video in my series on basic statistics. Now, a few things before we get started. Number one, you might notice by my voice that I'm just getting over a cold, so I apologize if I am hard to understand at times. I will try to dictate and speak very clearly for you. Number two, if you're watching this video because you are struggling in a class,
Sir, can you increase the volume of this video?
head up. you're watching this, it means you've accomplished quite a bit in your educational career up to this point. You're very smart, and you may have just hit a temporary rough patch. Now, I know with the right amount of hard work, practice, and patience, you can get through it. I have faith in you, so should you. Number 3, please feel free to follow me here on YouTube and or on Twitter. That way, when I upload a new video, you know about it. And on the topic of the video, if you like it, please give it a thumbs up. Share it with classmates or colleagues. Put it on a playlist, because that does encourage me to keep making them. And finally, just keep in mind that these videos are meant for individuals who are relatively new to stats. So I'm just going over basic concepts. And I will be doing so in a very slow, deliberate manner. Not only do I want you to understand what's going on, but also why. So all that being said, let's go ahead and get started. So this video is the next in our series on bivariate relationships. So in previous videos, we talked about covariance, and we looked at scatter plots and really tried to understand what covariance was. So this video is sort of the next topic in that series, correlation. So correlation is a standard topic in introductory stats courses. You often hear about it on the news or when reading, of course, scientific academic journals. So we're really going to break it down, understand what it is, and how it relates to other measures of bivariate relationships. So here was the example we used in the covariance video. Now, this scattergram here in the middle is a chart that looks at the monthly returns for the S&P 500 and the Dow Jones Industrial Average during the year 2012. So it's the monthly return for each index. So over on the right, you can see the returns in decimal form. So you just have to move the decimal over 2 places to get the percentage. So again, this is just a scatter plot, and I always recommend looking at a scatter plot of your data when you're looking at bivariate relationships. Now, the first question we want to ask ourselves is, how would we describe the shape or the pattern of these data points? Are they in a line, or are they in a curve shape? Is there no real pattern at all? Now, in this case, they seem to follow a linear pattern. So you can see if we put a line over the points, they seem to follow that line pretty closely. Now, what this means is that when one stock index rises, the other one also rises. And this is very important to understanding covariance and its cousin, correlation. So, of course, they follow a linear pattern. Now, in a real-world practical sense, this had better be the case. Well, why? Well, the S&P 500 and the Dow Jones Industrial Average claim to measure basically the exact same thing, and that is the performance of the overall stock market. So if they are not behaving in similar ways, then we have a problem because they are claiming to measure the same thing. So this relationship should not surprise us at all. Now, we said that 2 variables show this type of pattern. They have a positive linear relationship. When one variable moves in a certain direction, the other tends to move in that same direction. We call this the covariance. It's how they co-vary or vary together. Now, let's talk about linear relationships in general. Now, the covariance, and this is just a quick review, is one of a family of statistical measures used to analyze the linear relationship between 2 variables. How do 2 variables behave as a pair? Now, we have the covariance, which we talked about in previous videos. We have the correlation, which we're going to discuss in this video, and linear regression, which of course is related to the covariance and the correlation. So all of these measures are ways to look at the relationship between 2 variables. So let's talk about the difference between the covariance and correlation. Now, the covariance provides the direction, so a positive, a negative, or near zero. It provides the direction of the linear relationship between 2 variables. while the correlation provides direction and strength. So remember, the covariance does not tell us anything about the strength of that relationship, just the direction. The correlation overcomes that limitation by describing the direction and the strength. Now, the covariance has no upper or lower boundary, and its size is dependent on the scale of the variables. So for the covariance, you're going to get a number that is related to the scale or the measure of the variables themselves. However, the correlation is always between -1 and +1, and its scale is independent of the scale of the variables themselves, which is very handy because it allows us to compare variables that are measured in different ways. So we could look at the correlation between the temperature outside and our energy usage in kilowatts, which are obviously in different measures. We can look at various relationships across variable pairs regardless of the units they're in. That's why correlation is very handy. Now, another way of saying that is that covariance is not standardized while correlation is standardized. In the same way that a z-score is a standardized measure of the variation in a one variable. So you can think of z-score, the z-score of 1 as z-score of -2.3. The standardization in the z-score allows us to compare variables that are measured using different scales. The correlation behaves exactly the same way. It's a standardized measure of the relationship between two variables. Now, there are a couple things to keep in mind when you're interpreting correlation measures. Number one, before going crazy computing correlations, look at a scatter plot of your data. What pattern, if any, does it exhibit? So a lot of students I work with are always gung-ho about calculating or putting the data into a statistical software package or Microsoft Excel and calculating the correlation without actually looking at a scatter plot of the data. Always look at a scatter plot first. The correlation is only applicable to linear relationships. There are many other types of relationships that can exist between two variables, and we'll look at those here in a minute. For example, if we were going to look at a scatter plot of energy usage versus the temperature outside, and I live here in the Midwest, so our seasons vary quite a bit, what you'll notice is that when the temperature is very low, the energy usage goes up. Now, as the temperature rises to a moderate amount, the energy usage goes down. But then when the temperature gets really hot, energy usage goes up again. So the scatter plot will probably look like a U shape. And of course, that's a curved shape. It's not linear. So you always want to use the scatter plot to look at the shape of your data and realize that correlation is only applicable to linear relationships. Number three, and I'm sure this is hammered into your mind in your classes, and that is correlation is not causation. Because there's an idea called spurious correlation, and that's when two completely unrelated factors that may have a mathematical correlation but have no sensible correlation in real life. So maybe we measure the number of times our dog barks, and we keep that data in relation to whatever phase the moon is in. So maybe our dog barks more when there's a full moon, and it barks a little bit less when there's a 3/4 moon. It barks a little bit less when there's a half moon. So this relationship, this correlation exists, but it doesn't mean anything in real life. So the moon is not causing our dog to bark more or less, and our dog barking is certainly not causing the phase of the moon. So correlation is not causation. And finally, a correlation strength does not necessarily mean the correlation is statistically significant. Now, we're not going to talk about statistical significance with respect to correlation in this video, but just keep in mind, it just depends on the sample size that we're working with. So whether or not a correlation is statistically significant will depend on its sample size, but we'll save that for another video. I just wanted to point it out. So here are some general correlation patterns. And again, I'm sure these are probably in your stats book. You've seen these before. So on the left-hand side, we have a correlation where all the points seem to follow a positive upward trend along a straight line. So this correlation on the left-hand side is probably near +1. In the middle, we have the points that follow a negative relationship. So it starts at the upper left and goes down to the lower right in a straight line pattern. So this correlation is probably near -1. And then on the right-hand side, there seems to be no linear relationship at all. So the correlation of these points is probably near 0. Now, in real life, our data is probably going to be somewhere between these extremes. So we're not going to have data that looks like the +1 and -1 general patterns, and data that, well, we probably will have data that does not have a correlation that will look like the one on the right. But when data does have a correlation, it's going to be somewhere between the plus and -1 extremes and the 0 example. And again, that just comes with looking at the scatter plots of your data. Now, data, like I said before, does sometimes follow non-linear relationships. So on the left-hand side, we call this a quadratic relationship. And this might be a good example when I was discussing energy usage and the temperature outside. So if the x-axis down there at the bottom is the temperature outside, when the temperature is really low, we might use a lot of energy to warm our houses. As the temperature becomes more moderate there in the middle, we might actually turn the air conditioning or the heat off completely, open the windows, and therefore we're using very little energy. But when the temperature rises and becomes uncomfortable, we're likely to turn the air conditioning on, and then our energy usage goes up again. So in that case, it might follow this U shape, which of course is nonlinear. Then we have an exponential pattern, which comes into play in some areas of biology and demographic data and things like that. But again, it's not linear. It follows this curve that gets steeper as it goes up. And then we have a polynomial relationship. So this kind of has a S kind of squiggly curve shape, and we sometimes see that in data. So again, these are not linear. So again, you have to look at a scatter plot of your data to make sure it is applicable to doing correlations. So again, here is our example of the monthly returns of the S&P 500 versus the Dow Jones. So when the S&P goes up, the Dow Jones tend to goes up. And again, that should make sense. Now, I ran these numbers through SPSS, which is one of several statistical software packages. You could do this easily in Microsoft Excel. You could do it in SAS. You can do it in Minitab, whatever software you have at your disposal. You could also do it on a TI calculator. Well, what this tells us is that the correlation is 0.974. So you can see that falls in the diagonals there from lower left to upper right. Now, you can see that the correlation between the S&P 500 and itself, of course, is 1, and the same holds true for the Dow Jones and itself. The correlation is 1, because anything correlated with itself is 1. Now, between the two variables, the correlation is 0.974. And I did not point out that we use the letter R, lowercase r, to denote the sample correlation coefficient. So again, in this case, it's 0.974. But we'll talk about the correlation formula and coefficient here in a second. Now, it should make sense that the correlation is this strong, because remember, the highest it could possibly be is +1. Well, 0.974 is pretty close to 1. And that should make sense given the way our data looks and what we're measuring in the real world. Let's talk about the correlation formula a bit. And I'm not one to really harp on memorizing formulas, But I just want to point out sort of where this comes from and how it relates to other things we've talked about. Now, R is called the Pearson correlation coefficient. So in your book or in your class, if you hear the term Pearson correlation, that's what we're doing here. There are other types of correlations, but the vast majority of the time, especially in an
Okay, guys, we are not left with much time now. So we have to stop this video here. I'll continue this in the next class. And then I'll discuss more about correlation. Okay?
Okay, sir.
Yes, sir.
All right. So that's all for today. Thank you very much, guys. Have a nice day ahead. Bye-bye.
Thank you, sir.